Today's video is on the problem related to Laurent series, and this topic is from complex power series. In today's video, we are going to expand 1 by z square plus 1 into z square plus 2 in positive and negative parts of z if 1 less than mod z less than root 2. See here in the solution, so what is f of z given? So f of z is given as 1 by this is z square plus 1 into this is z square plus 2. Now I am going to resolve into partial fractions. So f of z, so this can be written as this is az plus b by z square plus 1, and again this is cz plus d by this is z square plus 2. Now we are going to find out the values of a, b, c and d. Therefore, this can be written as 1 by this is z square plus 1 into this is z square plus 2 is equal to. So, if I take LCM here, that is z square plus 1 into this is z square plus 2. So, this is a cross multiplication. That is az plus b into this is z square plus 2 plus, now you have to multiply cz plus d into this is z square plus 1. Now cancel the denominators on both sides. And what is the equation remind here? So this is 1 is equal to this is az plus b into z square plus 2 plus this is cz plus d into z square plus 1. Now there is no possibility of substitution. Therefore, the highest degree here is z cube. Now comparing z cube quotients. So z cube quotients here, z cube quotients is 0 and here a into z cube. So this is a, quotient of z cube is a, and here c into z cube plus c. Clear? And now comparing z square quotients on both sides. Here in the left hand side they are known, quotients of z square 0, and here if you see z square, so b into z square, so the quotient here is b, and in this d into z square, so plus d. Clear? And now the quotients of z, so this will be az into 2, so this will be 2a is the quotient here, and here in LHS side there is no quotient of z, and here this is cz into 1, this will be c will be the quotient on comparing constants. So constants, here the constant is 1, and here if you see this is b into 2, this value is 2b, and here d into 1, the value here is d. Now I am going to solve for a, b, c, d values. Now, if I solve these two equations, see here, this is a plus c, this is 2a plus c is equal to 0. So, if I minus subtract, so this will be minus a is equal to 0. So, a value is equal to 0 and therefore c is also 0. Clear? So, we got the a value and c value as zeros. And next one, on solving these two, that is b plus d is equal to 0 and this one. See here, this is b plus d value is equal to 0, and here this is 2b plus d is equal to here 1. And if I subtract, see what happens, d cancelled, and this is minus b is equal to minus 1, so b value is equal to 1. So if I put in this equation, that is b plus d is equal to 0. So 1 plus d is equal to 0, I got the value of d as minus 1. Clear? So here I got b value as 1 and d value as minus 1. So here in this equation, so we got a value as 0. So this value as 0, and next one c value as 0, and b value is equal to, see here, b is equal to 1, d is equal to minus 1. So b is equal to 1 and d is equal to minus 1. Therefore, our f of z value becomes, see here, if I substitute a as 0, b as 1, c as 0, d as minus 1. See, our f of z value will become, this is 1 by z square plus 1 minus 1 by this is z square plus 2. Clear? Now our f of z value turned like this after substituting a0, c0, b1, d minus 1. Now what is the region given? So this is 1 less than mod z less than root 2. See here, 1 less than mod z less than, this is root 2. And therefore if I square throughout the equation, that is 1 square less than z square less than, this is root 2 square. So this will be 1 less than z square less than root and square got cancelled, and this is simply 2. And therefore using this one, see here I'm going to expand. So our f of z value is very clear as f of z is equal to, see here, f of z value is equal to, this is 1 by z square plus 1 minus 1 by z square plus 2. And here the region is 1 less than z square less than 2. And see f of z is equal to, see here among z square and 1, see here which one is greater one, z square is greater, and therefore from these two terms I am taking z square common. This will be 1 plus 1 by z square. Clear? Among z square 2, see here which one is greater one, 2 is greater, so I am taking 2 common from this, 1 plus this is z square by 2. Clear? According to this region, I have to take z square common from this and 2 common from this. So I am taking to the numerator. So this will be 1 by z square into 1 plus 1 by z square inverse. This is minus half times of 1 plus z square by 2 inverse. Now here is an expansion, that is we have to use this one. 1 plus x inverse, it can be written as 1 minus x plus x square minus x cube plus and so on. So using this expansion, I am going to expand as f of z is equal to, see here, this will be f of z is equal to 1 by z square times of 1 minus z square plus 1 by z power 4, and next minus 1 by z power 6 plus and so on. Here this is minus half times of, this will be 1 minus z square by 2 plus square. So this will be 4 by 2 square 4 minus cube. This will be 2 cube. This is a 6 by 2 cube. This is 8 and so on. And so on. So this value is 6. And therefore, so if you write properly this one, so f of z value is equal to, this is 1 by z square. This can be written as, see here properly, if you see, this can be written as, if I send this z square inside, if I multiply with z square, 1 by z square minus 1 by z power 4 plus 1 by z power 6 and so on. Here also, this will be minus half. So this is, if I send this minus half inside, this will be minus half plus this is z square by 2 square minus z power 4 by, this value is 2 cube plus this is z power 6 by, this is 2 power 4 and so on, and so on. So this can be written as, so f of z can be written as a, see here, so this will be sigma n is equal to 0 to infinity, alternate plus or minus, therefore minus 1 power n 1 by, so here the value here is 1 by z power, this is z power 2n plus 2 plus here also sigma n is equal to 0 to infinity. This is minus 1 power n plus 1. Here in the numerator even powers, that is z power 2n by 2 power n plus 1. So if you put n is equal to 0, so you will be getting this one. If you put n is equal to 1, so this will be z power 1 by z power 4. If you put n is equal to 2, so 2 3s is 6. If you put n is equal to, see here, 0 this one, 1 this one, 2, 2 2s are 4 plus 2 6. And likewise here also, if you put n is equal to 0, you will be getting half. If you put n is equal to 1, you will be getting z square by 2 square. If you keep n is equal to 2, you will be getting z square by 2 cube and so on. So this is the final expansion using Laurent series for the region 1 less than z square less than 2. See here, first of all, what I have done. So this is the function here. Now we have to resolve into partial fractions. So inner there is a power. Therefore, this can be written as az plus b and cz plus d. And we need the values of a, b, c, d for that. So here are the quotients of z cube, z square, z and constants. So after taking all the quotients of z cube, z square, z constants. So here I got a value 0, b value 1, c value 0, d value minus 1. After substituting, I got f of z value as this. and therefore the region given is 1 less than mod z less than root 2 after squaring. So I got this one. So this will be the expansion among 1 and z square is the greater one, therefore I have taken z square common, and among z square and 2, 2 is greater one, so that's why I have taken 2 common from these two and I have taken to the numerator, and after expansion this is the final answer. Thank you so much for watching. If you really like, please practice, pass it on to your friends, and subscribe to this channel. Thank you so much.